Welcome back, and in this video, the third in the series, I want to talk about how DNS works. I'm going to cover the structure and the flow of making a DNS query. So let's get started. Now I want to quickly touch upon the core functionality that DNS brings. If we abstract away from all of the technical details for a second, we have a person, device, or service. It has a DNS name and it needs an IP address which provides services for that name. So in this example, we have www.netflix.com and we need the IP address or addresses which we can connect to in order to access Netflix. Somewhere in the world, there is a DNS zone for Netflix.com which has the answer that you need. It contains a record which links www.netflix.com to one or more IP addresses. The issue is, how do we find this zone? Well, that's what DNS does. It's the job of DNS to allow you to locate the specific DNS zone which can provide you with an authoritative answer. So you can query it and be provided with a response, the IP address or addresses in this example which provide the services for www.netflix.com. Everything we talk about next, it's all part of the process to allow you to find the correct zone. So DNS is a huge global distributed database containing lots of different DNS records, and the function of DNS is to allow you to locate the specific zone which can give you an authoritative answer. So let's step through how a query works within DNS. In this example, imagine that we're sitting at a computer and we're querying for www.netflix.com. The first thing to be checked will be the local DNS cache and host file on the local machine. The host file is a static mapping of names to IPs and overrides DNS, and so it's checked first. Then the machine, and potentially the application being used, might have some local DNS caching, and so that's checked before we proceed with the query. Assuming that the local client isn't aware of the DNS name that we're querying, this is where we move on to the next step, which is where we use a DNS resolver. A resolver is a type of DNS server often running on a home router or within an internet provider, and it will do the query on our behalf. So we've sent the query to the resolver and now it takes over. Now from the resolver's point of view, first, it also has a local cache which is used to speed up DNS queries, and so if anyone else has queried www.netflix.com before, it might be able to return a non-authoritative answer. And remember, it's non-authoritative because the only server which can give an authoritative answer is the one which is pointed at for a given domain from the TLD zone of that domain. Now, since the resolver isn't that, while it can cache results, it will always return them as non-authoritative. In most cases, nobody will care, but it's important to understand the distinction. Now, let's assume that there's no cached entry for www.netflix.com. Well, the next step is that the resolver queries the root zone via one of the root servers. Every DNS server will have these IP addresses hard-coded, and this list is maintained by the operating system vendor. The DNS root won't be able to answer us because it isn't aware of www.netflix.com, but it can help us get one step closer. The root zone contains records for .com, specifically name server records which point at the name servers for the .com TLD. This is how trust is created and how the root zone delegates control of the .com TLD to VeriSign. So the root servers will return the details of the .com name servers. Now this isn't exactly what we're looking for, but it does bring us one step closer. So the resolver can now query one of the .com name servers for www.netflix.com. Assuming that the netflix.com domain has been registered, the .com zone will contain entries for netflix.com. This is how VeriSign delegates control of the netflix.com domain when the domain is registered. And so the .com name servers, while they can't give the resolver the answer that it needs, they can help it to move one step closer. And so the details of the netflix.com name servers are returned to the resolver. Well, now the resolver can move on, and so it queries the netflix.com name servers for www.netflix.com. Because these name servers are authoritative for this domain, because they host the zone and zone file for this domain, and they're pointed at by the .com TLD zone, they can return an authoritative result to the query back to the resolver. Now the resolver caches the result in order to improve performance for any of the same queries in future, and it returns this result through to the client, which is our machine. This is how every DNS query works. Some may be quicker if they're cached, or longer if the full walking the tree process needs to occur. The key facts to keep in mind are that firstly, no one single name server has all of the information, not even the root name servers. But, and this is key to how DNS operates, every query to every name server moves you one step closer to the answer. The root gives you the .com name servers, the .com name servers gives you the netflix.com name servers, and the netflix.com name servers will be able to give you an authoritative result. And this process end to end is called walking the tree. Now this is the process from a high level, but technically how does it look? Well, let's check that out. We start with the root zone, and I've skipped a few steps to step 4 when the resolver is querying the root zone. The root zone doesn't have the information needed, but it does know which name servers handle .com, and so it can provide this information. These are a subset of the name servers run by VeriSign which manage the .com TLD. So these are the servers which host the .com zone file. So we can now query the .com zone. We can't get the answer directly from here, but it does know which name servers are authoritative for Netflix.com. So these are the network addresses of the servers which host the Netflix.com zone. And this is authoritative, so this will give us the answer that we need. But in this case, it's not an IP, it's another DNS name. This is a CNAME record, and I'll talk about these in another video. But what this means is that to get the IP address for this, we have to follow the same process through again. That's right, many queries like this end with another DNS name, which requires another query. One of the many reasons an application can perform badly is if many DNS calls are used within the application and network performance impacts these in a negative way. So this is how the walking the tree process works end to end. This is how every DNS query works when you're trying to look up the IP address for a given DNS name. This architecture and this flow is at the core of how most internet-based applications work from a DNS perspective, and it's a really critical set of knowledge to understand fully. But at this point, that is everything I wanted to talk about in this video. Thanks for watching, go ahead and complete the video, and I'll look forward to you joining me in the next.